Welcome back, everybody. In the previous video, we took a look at activating and working with physical interfaces on ASAs. In this video, we're going to be focusing on sub-interfaces. So this is going to be leveraging .1Q tagging and things like that. We're going to be adding a couple of VLANs on the switch to allow that traffic separation, and we're going to do a little bit of work ahead of time to get that to work. So the trunking, the VLANs, all that type of stuff. Core layer 2 stuff that if you're at the CCNA route switch level should be a piece of cake for you to do. But we're going to go run through it real quick here since I want to have that pre-built before I go through the process of the other stuff, which is the layer 3 component. So on switch 1, let's go ahead and get that one out of the way first. I'm going to go to global config. I'm going to create VLAN 10 and VLAN 20. And it really doesn't matter what VLAN number you use, just use something. And then we're going to go and we are going to say do show CDP neighbors. Let's see if it's actually going to show up. Oh, it does. Okay, cool. We're going to say on is it gig 00 and gig 0/1, I believe. Let me just hop over gig 00, gig 0/1, and gig 1/1. Okay, perfect. That is what I'm going to use. So exit out interface range gig 0/0 and through 1. Yeah, 1 should be enough. And then gig 1/1. And we'll type in switch port trunk and cap.1q. Switch port mode is trunk. So we'll have that. And then we will add, my goal is to add test 9 and test 10 to VLAN 10. So interface range gig 0/2 through 3. Switch. Let me fix that up real quick. We'll type in switch port mode is access. Switch port access VLAN 10. Spanning tree port fast. And then we will say on interface gig 1/0 switch port access VLAN 20. Or I'm sorry. Yeah, we'll do 20. And then we'll do switch port mode is access. And actually I have to go and create one more VLAN, VLAN 30. And exit out. We'll do the same thing on switch 7. On switch 7 we'll come in here and do global config, VLAN 10, 20, 30. And then we'll exit out. That'll create those VLANs. We'll type in interface gig 0/1, switch port trunk and cat.1q, switch port mode is trunk, and then interface gig 0/2, switch port access is VLAN 30, switch port mode is access, spanning tree port fast. Okay, now that we have all of that squared away, we've now built the layer 2 communication between the servers, server 2, the test routers, and all that communication. So we know that should be working now. So now that we have that squared away, now we can go back to ASA 1 and we have to reconfigure what's going on here. Because right now, if we do a show interface IP brief, we have just the physical interface gig 0/2 and gig 0/3 currently deployed. So now I don't have to go through and actually define the DMZ if we do a show nameif. Because right now gig 0/3 is pointing towards the DMZ. I don't have to put that one as a .1Q sub-interface, but I'm going to do it anyway because I want you to see that the sub-interfaces can be sub-interface communication to other sub-interface communication. So gig 0/2.10 and gig 0/3.30, there will be communication there. So what I'm going to go ahead and do now is I'm going to say interface gig 0/2. I'm going to type in no nameif. That should take everything off. Show run interface gig 0/2 and no IP address. Do the same thing for gig 0/3. No nameif and no IP address. So show interface IP brief. Bingo. The interfaces had to be up still, but you're not doing anything with the physical interface. You're doing it with the sub interface. So in this case here, gig 0/2.10, And instead of saying encapsulation like you would on a router, you would have to type in VLAN. VLAN 10, and then it's going to be IP address of 10.100.10.1/24. And then you type in name if is going to be, we'll say inside underscore VLAN 10. Now, because I didn't use the inside keyword, it automatically gets the security level of 0. So I need to set the security level to this guy to be 100. Now I'll do the same thing. I'll hit the up arrow half a dozen times, and I'll get to type in .20, VLAN 20. The IP address is going to be 20.1, and then I'll say that the name if is also going to be secure, will be VLAN 20, and then the security level for this guy will also be 100. So we can do that same security traffic permit intra interface. So we have that now done. Now I have to go over to interface. Let's just recap what we've done. So verify, verify, verify as you're going along here. Show name if, show interface IP brief, and we have those interfaces up and running. We know that they're there. Now what we get to go do is type in interface gig0/3.30 VLAN 30 and type in IP, or we can type in the IP address 172.16.30.1/24, and then IP address. There's a weird thing normally in iOS when you type in the Control-A command to go back to the beginning of the line, or that way, depending on how you want to look at it. From where I'm at to where the behind the IP command is, you have to actually hit Control-A twice. So that's one of those little nuggets of information that I thought were useful. And then you need to say name if is going to be DMZ underscore VLAN 30. And I like to get specific with my naming conventions in this way so that I can pretty easily go, okay, well I know it's VLAN 30. It makes it more intuitive. So I'm going to type in security level for this guy is going to be 50. So show name if. I have all of that squared away. Show interface IP brief. Excellent. So now what I get to go do now is I get to go and I have to re-IP these guys in the server and make sure that the communication is going to work. However, if we do the show run begin same dash security, and of course it pulls up interface, right? So that's going to allow the communication between test 9 and server 2, right? And if we do a show run policy map, we're going to see that ICMP still is enabled. So we will be able to ping back and forth. Now, let me just do this real quick. Show interface IP brief. We have 10.1.10.1. So that means that test 9 and test 10, their IP addressing doesn't need to change. Test 11 needs to go to, this guy needs to go to 10.100.20.11. So let's go change that real quick. Show IP interface brief. Interface gig0/0 IP address of 10.100.20.11/24. And we're going to type in, let's say, do show IP route. I don't think I turned IP routing off. No IP routing. So we have that squared away. And we'll type in IP default gateway of 10.100.20.1. So we have that. So now we have that one, we're going to go ahead and pull up our VNC connection here, and we're going to go to close this out, and then we're going to go change the IP address on this interface to be we're going to say instead of 172.16.30 or 100, it's going to be 30. And there we go, so 30.1. Click OK, close, close. So there we go, we'll click over here, we'll type in, yes, that's fine. Click on here, we'll say IP config, make sure it actually changed. It did. And let's go over here to ASA1, and we're going to jump out of global config. We're going to do a show ARP. Am I learning anything? I actually just did, so I can ping it. So I should be able to ping 172.16.30.10, and I can. That's a great sign. Can I ping 10.100.10.10? I can. Can I ping .9? I can. Can I ping 20.11? Might take it a minute for it to... There it goes. Perfect. Excellent. Let's go check on switch 1, and we'll do a show MAC address table dynamic. Excellent. So we have reachability. We can see VLAN separation now. Do show interfaces trunk. And we know everything is coming together now, guys. This is epically cool. I think so anyway. So now we have that all squared away. Next thing we get to go do is what? Is test traffic between. So the same security traffic interface command is still there. So I should be able to go from test 9. I should be able to ping 172.16.30.10. Excellent. I still can. Let's do that telnet to that I was doing before, 30.10. It's trying. It is still enabled. Let's see if it's going to actually work. Okay, connection timed out. So that's not necessarily a bad thing, but it's not great either. So, in that type of a situation, let me go ahead and just close this guy out. Now we need to figure out, okay, 3389 is enabled, and all that good stuff. And we're supposed to be listening at 3389, which we are, which is what we need to see. So now we have to see, okay, why was it blocked? So I'm going to go ahead and try this one more time. Telling that to that port. I'm going to come over to the ASA. I'm going to do a show con long. And it's trying. It is for sure trying. And we have an SAA. Small s is an awaiting outside SYN. Little a is awaiting outside ACK to SYN. And big A is awaiting ACK to SYN. Awaiting inside ACK to SYN. So we have a little bit of a communication problem here. So in this particular case here, we're not sure exactly why it's not working, but we know it's not. So before it was working just fine. Now, when we talk about this, we're talking about going between interfaces, right? And this can be a little tricky to troubleshoot sometimes. So at the moment, I don't know what's wrong, right? So the way that it should be working is test 9 goes through the switch, hits the ASA. The ASA looks in its routing table and then points that traffic back out towards server 2. Server 2 then responds with it, and then this guy opens up the connection like we saw in the previous video. And the connection should show up and all that stuff would be hunky-dory. But that's not happening right now. So we need to figure out why. So let's go and take a look at a feature that you may not be familiar with. If you are, excellent. That's a great step. Let me go ahead and adjust my chair real quick. We're going to use what they call packet tracer. So packet tracer, and we're going to say input is going to be on the inside VLAN 10. So inside VLAN 10, and we're going to say for TCP with the source IP address is 10.100.10.10, and the port number that we're trying to connect to is just some high random order. So we'll say 30,000. And the destination we're trying to connect to is 172.16.30.10 on the port number of 3389. And we want to look at this and see, okay, why is it not being allowed through? So let's go ahead and see what's going on here. So let's take a look at from the top down. So just to recap what I typed in packet tracer. I want traffic that should be coming in on the inside VLAN 10 interface with as a TCP as a transport from 10.100.10.10 to, or I'm sorry, .9 should work as well. Actually, let me just redo that real quick. .9, which is more accurate. .9. So that should, okay, so it does a route lookup. It says, okay, I know where to go. It says it should be pointing at VLAN 30. And then we go, there's no NAT, so it's being allowed. We're not doing any NAT at all. The IP options, allow. QoS, nothing there. QoS on phase 4 and phase 5. Phase 6 is another NAT. 7 is a IP options is allowed. Flow creation, it's allowed. And which means it should be permitted, right? But it's not. So let me try that from 10. Let me go in here and do a show IP interface brief. Let's go ahead and do a ping to 172.16.30.10. Okay, I bet you I know what the problem is here. Show IP route. Yep. No IP routing. Let's try that again. Oh, I know what I forgot to do. Haha. IP default gateway is 10.100.10.1. Try that ping one more time. And the ping worked just fine. So we know that it works. So we know there's communication back and forth. So let's try the telnet to 172.16.30.10 on port 3389. This is kind of curious because it should be working. Now, it'd be one thing if I was trying to go from, for instance, if I was trying to connect to it in the same interface, that'd be a little bit different. But I'm not. I'm trying to connect to it on the same interface. So show con long. Okay, so there's no information there. So now what I have to go for, I had to figure out why it's not working. So I'll come back to that in just a minute because the premise of this video was to show that the communication will work. And let me do the R9 to R10 test. So, or I'm sorry, R9, test 9 to test 11. So let me go ahead and ping 10.100.20.11. Okay, that's working just fine. If I try to, let me go to test 11 here. Let's do a do show run section line. Line VTY0 space 4. Login local. Transport input is telnet, or I should say all. And then we'll say username is Rob, privilege level 15, password is Cisco, and that's it. So now if I go back to 9, I try to telnet to 10.100.20.11, type in Rob and Cisco, that worked. Okay, so let's go back over here to the connection table. So that's an open connection. Now, what's actually kind of funny about this, or at least I find it comical, is that this technically should not be working. At least in my mind, in my understanding, show run pipe include same dash security. This command, it should not be permitted because it's coming in and on the same interface. This should not be permitted. But let's do a show name if. And you'll notice that they're the same security level. So that, to me, that the way that I would interpret interface would be this communication between .10 and .20 would not be allowed. But it is. Let me go ahead and take this away. Type in no and pull this out. And let's try this one more time. Show con long. Okay, it's still there. So it's going to go ahead and we're going to say exit. And on 9, we'll say exit. Okay, so now I should be able to, can I still ping it? Okay, so that's not working. So let me go back to the ASA, and let's go to global config and type in same security traffic permit intra interface. Okay. And we'll say show con long. Let's go back to test 9 and try to ping that again. Still not working. Let me see if I show IP route. Routing is disabled, and the default gateway is set to 10.100.10.1. And let's do a show IP route just to verify. Default gateway is set there. So ping 10.100.20.1. Okay, all of that is squared away. All that is working the way that it's intended to. So let me go, now that with that same security traffic in, show run pipe include same security traffic permit intra interface, that should allow the communication between those routers, but it's not. Now if I was to go, I'm sorry, the ping isn't working, but if I was to try to do a telnet, still not working. Let's hit the up arrow and do a show connection long, not even triggering. So even though that command is out there and should technically be working, it is not. So what I'm going to go do is I'm going to do the same security traffic permit inter interface. So I wonder if it might not be a bug issue or something, but in my mind, that's when you're doing any type of what they call hairpinning, coming in on gig 0/2 and leaving out gig 0/2 just on 2 different sub interfaces, that should be traffic intra interface because it's looking at gig 0/2, not the sub interface. So now with that in place, I should be able to telnet to it, and I can. If I go over to the ASA and I hit the up arrow, I should have an active connection, and I do. Now if I go, and that's intra interface, and if I do a show run include same, I have both of them in here. So now I should be able to go to test 9 and be able to say, you know, let's say exit or Control-Shift-6X. If I try to telnet to 172.16.30.10, this is a little curious because it should be allowing the communication, but this guy's not receiving anything. He's not catching anything at all. Although pings do work. On 10, I can ping 172.16.30.10 all day, and it works just fine. So I'm a little not really sure why it's not being permitted through, but it's not being permitted nonetheless. So this was kind of a bust on the testing, but because all the testing I've done so far should be permitting it. And I wonder if there's a debug IP packet, debug IP. No, that's not what I'm looking for. I'm looking for debug. I wanted to debug what's actually happening behind the scenes. I don't know what that debug command is off the top of my head. ASP, that's ASDM. Show ASP drop. There's no real ACLs here either. So it's a little curious. Let me try this one more time from test 9 to there and see if it's actually triggering. So we'll telnet to 3389. So it's trying, and let's hit the up arrow. Okay, so it definitely is. So the one that incremented was the no route to host. Okay, so let's check that one. Maybe we're onto something here. Let's just double check something real quick. Show route. So let me do a show ARP. See, it's got a route. Let me just double check on this config here. I'm gonna type in IP config. Make sure the right default gateway is set. 172.16.30.1. So ping 172.16.30.1. Oh, Control Shift or Control C. I can ping it just fine. That's a little curious as to why. Let me try this real quick. Let me go type in interface, show interface IP brief, and let's go to interface gig0/3.30 and type in security level of 100. So the same as the other ones. Show name if. Now that it's all squared away here, let's try this one more time. So on test 9, that's going. And the ASA, so we're getting a number of hits on this no route to host, no route. But we have routes built in the routing table. So what I don't have is I don't have connectivity via the ASDM to look at what's actually happening. This is one of those times where having access to the ASDM is actually beneficial. But what I wanted to show you was that it does work communication-wise. That's partially working, the pings work, but for whatever reason, communication from the firewall or from the server back does not, which is a little perplexing as to why it's not working. That doesn't make any sense. Let me see what other ports are open on this guy that I can try. Let's see what else is there. There is 445, 135. So all these ports are open. 445. Let's try 445. Maybe it's a. I know that should be working. And really all we're trying to do is open up a TCP connection. That's pretty much it. And that's not working either. So I'm kind of surprised it's not working. We haven't gotten to the point of doing the redundant interfaces yet. So I just wanted to show you the same security aspect in doing the .1q sub interfaces. So I'm not going to spend any more time on this because I don't understand why it's not working. So let me go do this. Let me type in logging console is debug and logging enable. Okay, so I wonder if, let's try that one more time. Now that we have a live log, let's try this one more time. Let's try this from 3389. It worked before. So we're getting, so built an inbound TCP connection 83 from test 9 to the outbound connection. And it looks like it's going through the ASA 2, but failed to locate. Okay, it's failed to locate egress interface for UDP. So that's just DNS on this guy. So actually, I can turn that off. Tear down. So this one right here, tear down TCP connection 83 for inside VLAN 10 to DMZ VLAN 30. Duration of 30 seconds. There was no response. Like this guy didn't get the communication, which is a little weird. I'm not sure why that happened, but let me, because normally it would be a layer 2 problem or something along those lines, but it's clearly getting the connection. Unfortunately, I don't want to open up another one. One thing that, like, if I was troubleshooting this for real, and this was an actual problem that I had to resolve, I would download Wireshark, and I would be looking at, okay, why is it not coming through? Is the port, I see the port open, why is it not responding? That type of stuff. So, but here's one thing we can try. I can do this. I can go onto, let's pull up the putty session. Actually, let me do this. On test 9, I'm going to do a show IP, or show run pipe include HTTP. So IP HTTP server, HTTP authentication is going to be the local database. So what I should be able to do is I should be able to click on here and go type in 10.100.10.9 and hit the enter key. And it's connecting that way. I should be able to type in here and type in Rob and Cisco, and it should pull up CISCO. Did I not type in the password correctly? Let's do show run section user. Oh, username Rob, privilege level 15, password is Cisco. Let's try that one more time. So here we'll type in Cisco, and we get a connection. The connection does work that way. So let's go to A, and if we look at the connection here, let's actually show con long. We see a, let's actually tear this down and rebuild it. Let me minimize this guy real quick, close all this out, and try this one more time. We'll type in 10.100.that, and there it pulls up, right? So basically what ended up happening was, and I like this because it gives you the blow-by-blow what's happening. So this would be the same thing as looking at the real-time log viewer in the ASDM. So it says, this is for DNS, so it says build local host connection for both the VLANs. Build inbound TCP connection 89 from the DMZ to the inside VLAN. And then it says tear down the connection on port 80. And then it builds another one. But it's I find it funny, and I'm not exactly 100% sure why this happens, but the build up and the tear down happen very, very quickly. I mean, I get why it happens, because once the connection's been delivered, you no longer have to keep it open. That's why it does it, so that it doesn't open a security vulnerability. But it does work. So in that particular case here, this does work. It is working. It's just kind of weird that from what I'm going to probably end up doing is I will probably get rid of these test boxes here, and I'll probably deploy another. I'll probably get rid of one of these Windows PCs over here and put one over here. I say, well, why are you going to do that? Well, because I want to be able to test connectivity back and forth, because I'm going to be spending quite a bit of time on ASA v1, and I want to make sure it's actually going to work the way that it needs to. So it's nice to be the testing of the pings and stuff like that, but I really wanted to have the connectivity here. One of the things that you could do is you could enable in the server manager the HTTP server. That's normally what I would do. So in between this video and the next, I will actually probably get rid of these test routers here, and well, I might keep one, but I really want to be able to test connectivity between the DMZ and the non-DMZ, or the inside and the DMZ. But we can play around with that as we're going along. But or we could even use test 12. We can use that too. TCP connectivity, it really doesn't matter how we do it, but we could test that connectivity as well. So we'll deal with that as we're going along. Let me actually do this. Let me go ahead and pull this super putty up real quick, and let me bring this down just a touch. And on switch 7, I'm going to go ahead and global config interface gig 0/0. I'll type in switch port trunk and cat.1q. Switch port mode is trunk. I'm going to extend switch 7 to switch 2 and bring test 12 into the mix. So I'm going to go ahead and type in VLAN 30 and exit out so that it builds VLAN 30. Well, it should already be built. Then we're going to go to switch 2. Interface gig 0/3, switch port trunk and cat.1q. Switch port mode is trunk. And then interface gig 0/2, switch port access VLAN 30. Switch port mode is access. Spanning tree port fast. So now we have all that squared away. I'll click on test 12 and I'll put him in the IP address of no IP routing. IP default gateway is going to be 172.16.30.1, and then interface gig 0/0 IP address of 172.16.30.12/24, and then no shut the port. Now with all that being done, I'm going to go ahead and exit out of here and type in username is Rob, privilege level 15, password is Cisco, and then I'll type in IP HTTP server, and IP HTTP authentication is local, then line VTY 0/4, type in login is local, and transport input is all, just for the simplicity of the fact. Now with that done, what I should be able to go do now on the ASA is type in on interface gig 0/3.30, type in security level 50 here, which will make it show name if. It should bring that down to a lower security level. So I want to be able to have the flow going the correct way. So now that we have that in play, I should be able to come over here onto test 9, and I should be able to do a ping to 172.16.30.12. And I should be able to telnet to 172.16.30.12, and I can. Rob and Cisco. Pulls up, let's go over to ASA1, and let's check that table. So we look right here, there's the ICMP ping going out, tear down the ICMP ping. Then you have the build local connection from test 9 to server 12 going out, and the you see the response coming in, so the connection goes through, and then we do a show con long, and we have an active TCP connection from the DMZ to VLAN 10, or from, I should say, the DMZ to the inside, and it's working just fine. And that'll stay up as long as I keep it there. So that means is on server 1, let's go ahead and pull that up again, we should be able to go to here and type in 172.16.30. And I'm on the ASA 30.12, and I type in Rob and I type in Cisco. I go through. Now what you won't see is the communication for server 2 to test 12. I go, well, why not? Well, the simple reason for that is because the fact that, well, one, it's in the same subnet, in the same VLAN. So it hits the switches and goes through the switches. There's no routing through the ASA in order to get there. That's why that's happening. And also while I'm here, let's go ahead and disable the DNS for the moment, because I want to not have to worry about that as I'm going along. So we'll just say obtain DNS automatically. Let's just go ahead and say OK. I don't care for DNS right now. It doesn't matter, because I don't want to have this output right here keep popping up. But right now, we're 40 minutes in. We made a couple modifications. We tweaked the design a little bit, but the fact of the matter is we wanted to test connectivity. It bypasses some capabilities, but it still gets the job done. So, but what it does prove is it proves that from the high security zone to the low security zone, I can communicate. But if I was to try to reverse the path from 10, if I do a show users, if I do a ping to 10.100.10.9, the traffic is not going to be allowed. And if we look on ASA1, it's going to say deny inbound ICMP. And the reason why it's being denied is going from a low security level to a high security level. So I'm going to keep this this debug on and running, or just the logging, I should say, so you guys can see the hits as they're happening. Until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next one.